I'm going to talk about the weather. Going to see this low pressure here, but before it was like a high pressure. During a La Nina, it's a high pressure. It just forms some bridge-like shape, and then it gets cold air. The cold air from the Arctic gets blocked and forces the cold air to slam into the eastern North America. It then brings like stormier conditions because the warmer waters, warmer than normal temperatures, sea surface temperatures. But El Nino is the opposite. It brings low pressure, and then the more cold it is from here, it just smashes down to here. So when this El Nino, it just brings a trough, like brings a trough here, then massive rate just surge to the surges, surges to the northern U.S. and Canada, but that's a El Nino pattern, and brings a low pressure. When it's low pressure system, it's like somebody here, like you create near the equator. So when it's El Nino, the warmer the normal temperature just rises north, more north. The wind just pushes west to east. It brings below average temperature, above average precipitation, above average rainfall. So it's gonna bring like that. But during a La Nina, when it's like warm ocean temperatures, it's gonna move more south, and the cold dry air is also moving south, and it brings some thunderstorms moving to the east coast. So the when this thunderstorms like it's gonna move north from here. It's gonna move from here like near the equator all the way to the high pressure zone, like subtropical high pressure. Goes more south. But Enso neutral is near the equator. Like somewhere here, it's gonna be like tropical thunderstorms during Enso neutral sometime or something. So unless we control the magnetic field, if we don't control the magnetic field, Mars, we can't control the climate. So we can't control the climate without controlling them. Earth's no Mars magnetic field or Earth's whatever planets there. So same thing for other places. When it's monsoon season works, let's say it's same thing. It just goes like easy when the rainstorms from the equator. The rainstorms like actually right here, somewhere here. When it's like wintertime, it just pushes south. The earth still pushes south. And summertime, it pushes north. That's just a monsoon rainy season and things. So when is the like? So if we want, this only peony is only exists. Sometimes this is most of the time most extreme toughest North American pattern. It just exists in northern hemisphere beyond like not New York City, like New York City latitude or Santa Virginia or Carolina latitude. So it's gonna be like that. That's the most part of it. Just something that extends to Florida too. That's why the weather temperature changes so much. And like in Manitoba, southern Ontario. So like also like some high pressures is possible and like so strong enough to bring like desert climate like South America, even though it's not in part of Southern. So in this example, like something in South America just brings like subtropical high is strong enough as this to enough landmass to bring dry weather, dry climate. The hybrid is strong enough to bring like that. It's like being hot deserts. Like last week is like hot desert in somewhere in Colorado. It's like cold desert. You need an example for describing climate every. That's why warm summer, human continental, it's everywhere. Like if you're near the oceans around like you can say Canada, like here that's oceanic climate. So anywhere in like summer, this line is gonna be oceanic climate. It could be closer than that. Oceanic climate could bring some snow, but not enough for like perfect winters. If you look at the climate normals, like climate normals, you need to look at climate normals to see like how much centimeters snow compared to like human continental climate. It has more snow than oceanic climate. Like if you're closer to the ocean, it gets less snow. You could get some snow, but it's too warm because of the like moisture dried up from the water. It just when the water is dried up, it just forms clouds. All this moisture in the air just traps some heat. When it's so much water in the surface, it's gonna trap more and more heat. It makes moderate temperatures, like warmer winters and cooler summers. So, yeah. So the Earth, Venus, Mars core is cooling down since for billions of years. Also, Earth's core is cooling down very slowly, but slower than Mars. Mars also had a still has a magnetic field for a long time, but it's weaker, way weaker than Earth. But it's gonna get weaker for Earth. But Venus was habitable for once, except the sun got too big, too warm to Venus to have life. It was habitable for once, but it's too warm. The sun got too big and warm. It's also like it's like highland climate, like high elevation climate. It is just it does it like some like if you look at like ice cap climate, like ice cap climate is gonna move way far north in the future because of climate change or global warming. So it's for now it's like subart like ice cap climate should be in like borderline like Arctic, like near the Arctic Circle for now, like somewhere in the middle. So like for now, I just talked about the like current climate normals. In the future, we're like in 50 years, so it's 2071. It's the human continental climate is gonna go far north. If it gets severe, even monsoony, Ontario could get some warm summer human continental climate, possibly like hot summer continental climate, somewhere in central Ontario, possibly even cold actually. Somewhere is hot summer continental, somewhere way far north, like central Ontario, like close to like pretty more than southern Ontario, past to southern Ontario. It's also like in the future there's a weird like somewhere in this like somewhere beside Hudson Bay Lake, it could be polar oceanic climate, which is same thing as oceanic climate, but it just gets warmer winters, cooler summers than oceanic climate. So it's like more moderated than oceanic climate. Like yeah, for now it's a subarctic climate, like near the Hudson Bay Lake. It's not Hudson Bay. Yeah, this Hudson Bay Lake. It's kind of but if you look at like New Hampshire compared to Southern Ontario, it's gonna be like humid subtropical because of the lakes. And Montreal, Quebec gets some hot summer continental instead of humid subtropical because it's not just yeah, it's because of the like latitude and longitude rather. Because of geography. It's gonna be like hot summer continental. When you're away from the lakes, the climate just turns to the continental climate instead of humid subtropical if the climate gets severe. Right now, right now it's like a humid continental climate's way far some more farther south than southern Ontario. You need to find out like what climate, like open climate if you want perfect winters and perfect summers. We want to see perfect summers and perfect winters, but most perfect summers and perfect winters is away from the lakes and away from the ocean. Perfect winters and perfect summer at the same time. If you look at the climate normals, like yeah.